Today, we are going to learn how to find SQL injections in source code. We learned the fundamentals of SQL injection and also making exploits using advanced techniques in previous sessions. I recommend you watch these topics before getting into this session, the links to which are given in the description of this video. Now, with the basic understanding of SQL injection, we are going to see how we can identify SQL injection vulnerabilities in source code. You can also call this a static application security testing with a targeted vulnerability, which in our case is SQL injection. Let's jump into it. So for you to identify vulnerabilities in source code, you should have knowledge in at least one programming language. We are going to look at a code sample in the Java programming language today, but I will also touch upon APIs, functions and patterns in other languages such as .NET and Python, because with security testing, you are not going to write code, rather review code. So if you have knowledge in one programming language, it is usually quite easy to extend your reviews to other languages. Okay, let's see what really happens within an application where the code is written in a way that could allow SQL injection exploits. In the previous sessions, we observed how a front-end input gets translated into an SQL query, but for code reviews, we will have to expand further and see how the input values are supplied to SQL query. Let's see an example. Say you have a students table like you see in the screen. So the table has 5 column headers, namely first name, last name, student ID, department and date of birth, and it has 4 records, one each for each student. As a department administrative staff, I would like to retrieve the first name and last name of all students in the mathematics department. Now my underlying query will look like the following. Select first name, last name from students where department is equal to mathematics enclosed in quotes entered by a semicolon. Now imagine the administrative staff retrieving this input from the application front end. Say for example, the front end looks like the screen you see here. So there is this university web page where you are logged in as an administrator, and you have an option to click on a particular link which would result in retrieval of student information based on a department. Now you also have a drop down where you select the department name, and based on the department that you have selected, you will see the results. Say for example, if you choose mathematics, the results will look like what you see in the screen. Now the application code snippet for the above logic in Java will look like what you see in the screen. Department is equal to request.get parameter of department. String query is equal to select first name, last name from students where department is equal to the department value from the previous line, which was retrieved from the front end using request.get parameter API. Or if the application uses prepared statements, the code will look like what you see in the screen. Instead of having the plain query, you would have the query enclosed in connection.prepared statement, which is a function. In most programming languages, the plus operator is used to append values to existing strings. In our case, it is a query. For example, in our case, this entire statement within quotes is a predefined or static string or a text value to which a dynamic value, department value in our case, is appended during execution. In either of the above cases, the application makes itself vulnerable to SQL injections, and the reason for this is that the value supplied at the front end is added to the SQL query directly. Now, a malicious user can supply special characters along with normal input to cause SQL injection attack. Now, like I said in the beginning of the session, though these examples are in Java programming language, it is easy to expand this to other languages. Say for example, in .NET, for the same logic, instead of using request.get parameter API, the application programmer will use request.get query string or request.query string, which again is used to retrieve front-end values. Similarly, in Python, it could be request.get. Now, this doesn't mean these are the only APIs to retrieve input values. There are other options as well, like request.get attribute, request.get parameter values, etc. But the shortcut here is the moment you see values being taken from request, can safely assume it is coming from application frontend, which can be misused by an attacker. And when you see these input values taken from requests being used in SQL queries improperly, you can flag them to be SQL vulnerable. Now you heard me say values being added to SQL queries improperly. What do you mean by that? When I say improperly, I'm referring to how input values are added to SQL queries in an insecure manner. Again, we saw a few examples of how the underlying code will look like when a query is written and a database connection is made. None of what we saw would cause a functional issue. Everything seems to be written absolutely in a normal way, but the only concern is that there is a security issue. So how do we address that? Normally, there are two ways to prevent an SQL injection in code. One is via input validation and other by proper use of prepared statement via parameterized queries. Input validation aims at filtering out malicious characters and allowing only acceptable input, where parameterized queries consider the malicious characters as text and doesn't allow the database engine to execute the same. Let's look at examples. So let's rewrite the code by applying input validation. So the code that you see in the left side here is the actual code that we wrote initially, and the code that you see on the right side is a rewritten code with the input validation logic. So from the code that you see on the right side, in addition to retrieving values using the request.get parameter API, we are using a character pattern to validate if the department value that is taken from the front end meets the character pattern. In our case, alphanumeric, where we are saying the character pattern should have 0 to 9 numbers or A to Z, either in small letters or capital letters. Now, only if the department value, which is the input value taken from the front end, matches this character pattern, the query will be executed. If not, the application logic, this particular code snippet, will return an error message. So this code, now rewritten to use the input validation logic, will allow the query to be executed only if the supplied input has numbers and alphabets. In case there are special characters, it will return an error message. Now let's look at parameterized queries. One thing that you have to understand is that prepared statements in itself do not prevent SQL injection. Prepared statements with the use of parameterized queries can prevent SQL injections. Now let's rewrite the code. Similar to the previous example, the code that you see in the left side is the original code that we wrote using prepared statements, and the one you see on the right side is the rewritten code using prepared statements and parameterized queries. So on the right side, what you see is the query being enclosed within connection.prepared statement, but instead of having a plus operator and the department value being appended towards the end, we have a question mark. Now the question mark here is called the bind variable, and when the application and the database engine sees a bind variable, it appends the actual value as the text in place of bind variables. So the real difference here is with the use of prepared statements with the plus operator, your query will look like select first name, last name from students, where department is equal to the department value appended to the query enclosed within quotes and entered by semicolon. This is the result of prepared statement without bind variables, just by using the plus operator, which in case is vulnerable. Say now you supply the department value as mathematics, your query will now look like select first name, last name from students, where department is equal to mathematics enclosed in quotes ended by a semicolon. However, if an attacker supplies a malicious input, say for example mathematics enclosed in or entered with double quotes, union, select username, password from users, semicolon, double hyphen, your query will now look like what you see in the screen. So this is actually now a union of two queries, which will be interpreted by the database engine as two queries, and the results being consolidated together and returned to the end user or an attacker. And so the attacker will now be successful in making the database engine run a union-based query. Now, instead of just going with prepared statements with bind variables, with the plus operator, if you use parameterized queries in your prepared statement by the use of bind variable by using question mark, the entire value the attacker supplies, the entire phrase, the entire query with additional union operator and additional query that the attacker supplied will be considered a text and will be enclosed in quotes. So your query with the use of bind operators with parameterized queries will now look like select first name comma last name from students where department is equal to mathematics enclosed in quotes, union operators select username comma password from users semicolon double hyphen, and there is an ending quotes which says to the database engine that the entire value starting mathematics to the double hyphen to the end of it should be considered a text value and should not be considered as a SQL command regardless of what is there in the input value. Even if there is union, even if there is special characters, all of this will now be considered a text value, and the original meaning of the special characters when it comes to databases will not be interpreted. So the database engine will no longer consider the union operator or the meaning of special characters, but will rather consider all of the supplied characters to be text. And since there is no such department by name of these big long phrase with mathematics, union operator, and the query that is added to it, the database will not return any results. Keep watching for you to learn more about additional vulnerabilities that we will continue to explore in the upcoming sessions.